Okay, good morning everybody. Thank you very much for inviting me to give this presentation. So I'm going to be talking about evaluation of polar regions in ocean reanalyses, and this is a project that we initiated, initially the reanalysis comparison was initiated called the Ocean Reanalysis Into Comparison Project. I'll talk a little bit about that at the start. And then we have this EOS COST program, which is enabling us to continue that and to do these studies of the polar regions. And although I'm giving this talk, many other people have contributed to some of the things that I'll show. In particular, Petteri Uotila from Finland is sort of leading the preparation of this work at the moment. Matthew Chevaliers, who's here, has also contributed, and Hughes Goss from Louvain was initiated the program in COST. So many other people have contributed to this. So the outline of my talk this morning, I'll talk a little bit about the original Ocean Reanalysis and Comparison project and the community that was set up to do that and what we achieved with that. In particular, I'll say a little bit about the data repository we have, because that is now getting well established and it's available for other studies such as these polar studies, but also we'd be very keen to see other people starting to use it as well. I'll then introduce the COST project and talk a little bit about the ambitions that we have for this polar program, this polar comparison. And then I'll spend most of the talk just showing you some preliminary results that different people have produced. And these are very preliminary at the moment. We have a wiki page where people are sort of collecting stuff that they've done, and the intention is to integrate that together in order to sort of put the papers together that we're working on. And there's a number of analyses of the Arctic, and then there's some others of the Antarctic. Okay, so the original Ocean Reanalysis and Comparison project was a joint project between Clivar GSOP and the G'day Ocean View community. So we were really bringing together the climate interests of the International Clivar Programme and the real-time interests of the G'day Operational Ocean Forecasting Programme to try to bring the products together and to assess them in comparison. So we've got a lot of products that we were dealing with. You can see there on the left a number of people who contributed in setting up the original comparison program, and this was initiated in the summer of 2011, so it took quite a long time to get things going. You can see there in the middle there are a number of variables that we decided to focus on: ocean heat content, steric height, sea level, surface heat fluxes, mixed layer depth, salinities, 20-degree isotherm depth, sea ice, the Atlantic meridional overturning, and a particular focus on high-resolution model products. And so this was not a funded project. This was a project that people were doing on a best efforts basis. So different groups took the lead in these different areas, and they would then gather the different products, information on the different products for those particular variables, and try to put them together to do a comparison. And you can see on the right-hand side, there's a lot of different global ocean products out there that we managed to gather data from. So many from the US, from Australia, from Japan, as well as from Europe. So it was really there's about 16 or 17, well there's about 19 products over there. You can see on the left here, 6 of the products were observation only, so really just based on statistical analysis from data. There are 13 low resolution model products, 8 high resolution model products, 4 coupled data assimilation products, and 6 of them were actually long reanalyses starting in the 50s. The rest of them, the majority, are kind of 93 onwards, the altimeter period. And there's a summary paper led by Magdalena Balmaceda in Journal of Operational Oceanography, and there's now a special issue of Climate Dynamics which has 9 papers covering some of these different variables, and all those papers are online now, but there will be a special issue, print issue, gathered together. You can see that only one of these really explicitly focused on high latitudes. There was this paper on Arctic sea ice, which I will look at as we go forward. Okay, just a little bit about the data repository. So we chose to use the Hamburg data server as a repository for the information that we were putting together. So what we tried to do for these different products is extract the particular variable and present it on a regular grid. So moving away from the model grid, something on a regular Levitus 1 degree grid, making it easy for people to get at and make comparisons. So that extracted data was all put together and is going up on this server. You can see there on the right-hand side, this server was set up at Hamburg, so it also has the Gecko product in particular, was one of the original foci, but it's also hosted this Aura IP data. And Ramon Sadliki from Hamburg has been very responsive in helping us get these data products online and very quickly. One of the good things about the Polar project that we've been working on this last year is that it actually made us get the data that we already had from the previous project onto this server, so it is much more available now than it was just a year ago. And you can see here is a list of the products that were part of the program. Again, that's part of the web page. You can see the data that we have at the top there, and I just thought I'd show you this. This is the FTP site. And you can see on the left-hand side some of the parent directories on heat content, fluxes, mixed layers, sea ice. And there's a couple of new ones down the bottom that we're trying to gather data on surface currents, for example. And then if you burrow down, this is in the heat content pages, you can see all of the different products. These are all data sets showing annual mean quantities for different layer depths in the ocean, ranging from the top 100 meters down to 3,000 meters depth. So all those data are available and can be freely downloaded, and people can use them and make their own comparisons with things that they're interested in. So we think that's quite a nice data facility there. So this is just an example from the original reanalysis into comparison. This is from Matt Palmer's paper on the ocean heat content. And you can see what he did here, the sort of typical approach on the left-hand side. On the top left, we've got, this is actually showing interannual variability. So on the top left, we've got an ensemble signal. So this is the variability that's the same throughout the different products. So the higher the values there, it's showing you've got the same interannual variability in the different products. And then on the right, you've got the ensemble noise. So that's the spread amongst the different products. And then on the top right, you've got signal to noise ratio. So this is showing you areas where the products are actually agreeing with each other, and then areas which are of low values there are showing where products are disagreeing. And so this is giving us an idea of what we can actually say consistently about the state of the ocean. So this is the top 300 meters, and you can see that the highest signal to noise runs through the tropics and through most of the northern hemisphere. The southern hemisphere is still fairly blue there, fairly low, so that the data period we were looking at here was 93 to 2009. So about more than half of that period is in the pre-Argo period, so where we didn't have that much data in the Southern Ocean. And so you can see that the products are not actually agreeing with each other under those conditions. So they would have been forced with reasonably realistic atmospheric forcing, or reasonably consistent atmospheric forcing, but clearly there's still a lot of variability in the different products, which is not constrained by that. And then on the right-hand side, there's some plots of the history of the ocean heat content, and obviously we're very interested in how the oceans are heating up. And so this is trying to make comparisons in different layers of the different models to see if we could assess whether the global warming of the oceans was, to what degree that was consistent. So this is a typical sort of presentation we had in the earlier ORIP. Notice very difficult to see anything going on in the polar oceans from that kind of perspective, but of course there is signal in the polar oceans, and that's one of the things that we wanted to bring out in this polar IP project. So just carrying on now a little bit on the evaluation of ocean synthesis program. So this is a COST project which has been going for about a year and a half now. And it's really focused on bringing the community together who want to evaluate these kinds of reanalysis products. And it's obviously, if you're aware of COST, it's an open program to all COST countries, and we're very keen to bring in new people who'd like to sort of take a look at some of the reanalysis products and evaluate them according to their own expertise. So this Polar project, you can see here a list of people involved. Many different countries are involved here. And again, this is open. If people want to join this program and do their own studies, they're very welcome to do so. But the sort of aims that we had were to sort of make regional Arctic and Antarctic comparisons, and really to bring in more regional expertise. So many of these people were not involved in the reanalyses themselves, but they bring in expertise of the Arctic and Antarctic areas, and that's exactly what we want. We want experts in different regions of the globe to look at some of these reanalyses and tell us what's good and what's bad about them. So I say establishing this data repository, this is something that we've really cemented now because of the need to do that for this polar project. Benefit from the existing data that we have. You saw the previous projects there. Update some of the products with, obviously, as time moves on, people produce new versions. And also introduce some new variables, hydrography, currents, straight transports, for example, are things that we'd be very keen to start comparing amongst the models. And I said already, it's very much work in progress. We had a first meeting in March this year, and there's another one scheduled for November. And the immediate aim, is to have 2 papers, one on the Arctic, one on the Antarctic, ready for submission sometime early-ish in 2017. And we want to do more than we did with the previous Aura project. We actually want to have time to compare different people's analyses, because in the previous implementation of this, the people looking at ocean heat content didn't have time to look at the salt content as well. But given that we'll have this regional focus, there will be an attempt to sort of make the different products consistent and understand what we're seeing in different aspects of the circulation. Okay, just a few polar issues before I go on to some preliminary results. So the sorts of things that obviously we'd be very interested in looking at are Atlantic water pathways from the Fram Strait and the Arctic boundary currents, the Beaufort Gyre freshwater storage, which is thought to have a big interannual variability and may have impacts more widely, say, for example, in the North Atlantic. Heat and freshwater budgets, trends and transports within the Arctic. Sea ice seasonal cycle and trends. The Arctic halocline maintenance and variability. Antarctic sea ice means and trends. Mixed layer depth variability around the ACC transports, ocean heat content trends around the Antarctic continent, which may be responsible for encouraging glacial runoff around Antarctica, for example, in the ice sheets. So these are all sorts of questions. I don't know how many of these we'll be able to address effectively, but these are the sorts of things that we will have in mind as we start looking at some of the products that have been generated. Okay, so I'll spend the second half now just showing you some of the early results. And this is actually from the paper that Mathieu Chevalier led in the original Aura IP, looking at Arctic sea ice cover in these reanalyses. And this is really the first systematic intercomparison of the sea ice fields from such global systems. Okay, so this is the Seaice concentration, basically showing the extent of the sea ice and how that's varied through these last 2 decades. And you can see a number of the products there. At the top, the NSIDC observational assessment of the variability. And you can see that there's some broad agreement in terms of the downward trend in Arctic sea ice cover, but there's also quite a lot of variability amongst those products. But they're all broadly showing the similar ups and downs. If we focus in, however, on the thickness of the sea ice, this is something that's much more difficult to assess. You can see what is presented here is the thickness anomalies with respect to ICESat data. And you can see that there are a number of consistent discrepancies, particularly around northern Canada and north of Greenland there. There's very commonly thinner ice fields in these reanalysis products. Some of the products have much thicker ice fields elsewhere, sort of in the Beaufort Gyre there, for example. But you can see there's quite a lot of variability there. So this obviously gives you a reference point for trying to understand what some of the issues are in these different products. And of course, you also have to bear in mind that not all of these products would have had data assimilation going on in the Arctic. So some of them are more free than others. Some of them would have assimilated some sea ice information. And then Matthew looked at this aspect, and this is trying to just assess whether there's any memory or predictability in the sea ice variables. So this is looking at as a predictor of sea ice volume in the spring against the predicted sea ice extent in the summer. And you can see here, well, on the far right-hand side, you can see the, I don't know whether the, do I have a pointer at all? Is that a pointer at all? Maybe not.
Yeah.
It is? Oh, never mind. It's okay. You can see on the right-hand side that this is the biomass, so that's an observational analysis product, and you can see the area circled, suggesting that it's working now, is it? Oh yeah, got it. Okay, so suggesting that high sea ice volume levels in the spring is actually a predictor of high sea ice cover later in the summer, and sort of that there's a predictability element, you know, throughout that on that sort of a seasonal timescale. And this is just showing that some of the products reproduce some of that variability, but other products do not. So again, that's an interesting aspect to try to follow up on and to understand the dynamics of that. Okay, so I'll now, so that's already a published paper as part of the climate dynamics set. These are some new studies that we've been doing, essentially trying to do what Matt Palmer did, but just now have a focus on the polar regions. So this is showing mean Arctic ocean heat content anomalies from 93 to 2010. And again, on the top left here, you've got a mean Arctic heat content, and this is the top 300 meters only here. And then this is the spread amongst the products. And obviously this spread doesn't show much variability in the Arctic because it tends to be dominated by spread that's sort of at southern, you know, more southerly latitudes. But then what we've done here is for each of the products, we've shown the anomaly, the mean anomaly from the ensemble mean. And 4 of the products are actually observation-only products. And then the rest of these 10 are actually reanalyses, including the Topaz the Topaz product here. So this is part of the operational system. So this is the hindcast from Topaz. And what you can see here are the anomalies from the ensemble mean. And this is the ensemble mean of just the model products. So the observational products are not included here. The thing I just wanted to point out is that the anomalies that you see, and of course there are anomalies in the observational products, including some more recent ones. This is this one by Hiroshi, who's prepared at RV. So this is a very much ongoing work, reanalyzing a lot of the Arctic data. You can see that the anomalies that you can see in the observational products are not too different in size from the anomalies in the reanalysis products themselves. So that, you know, this discrepancy between the observation-only products is not actually much smaller than the discrepancy between the reanalysis products. So I think this is giving you an idea that there's a fair degree of consistency between, at least at these upper levels, between the reanalysis products, and there's some consistency with the observation-only systems. And so you can do the same for salinity, and this is again upper ocean salinity, the same thing. You've got a mean here, you've got a spread. You can see there's more spread here, particularly in the Beaufort Gyre. So this is telling you that there's quite a lot of variability in the salinity, the upper ocean salinity in the subpolar gyre, in the Beaufort Gyre. And again, you can see the anomalies of the observation-only products and the model products with respect to these. Some of them do show quite big anomalies here. This is the soda product from the US. This is the Japanese MOVE G2 product. But many of them are actually show a reasonable degree of consistency. Okay, so other people are looking specifically at the vertical structure. So this is work by Petri in Finland, and identifying 3 particular points in different basins, the Amerasian Basin, the Central Arctic, and the Nansen Basin, and actually looking at the stratification in the different products. And this is basically using those fields that we've derived. It's looking at the stratification between the top 100 meters down to 300, down to 700, 1,500 and 3,000 meters. So it's basically giving you some kind of rough idea of a vertical profile and how they differ between the models. So, and both temperature and salinity have been looked at here, and this is also an attempt to look at how the TS relationships in these different layers are varying. So I'm not going to go into details of some of this, and this is obviously something that we're still digesting ourselves, but it gives you an idea that we can make some assessment of the thermocline and the halokine structure in these products. And obviously also, as well as the means, the sort of layer trend analysis will also be performed to sort of see to what extent we can detect changes going on in these different layers in the Arctic. This is some work by Dorotea Iovino from CMCC, and this is showing, this is the liquid freshwater content in the Arctic from some of the different products. So again, this is showing some of that large variability in the subpolar, in the Beaufort Gyre between the products. And again, that's this is going somewhat deeper than the picture I showed before. I think this is going down to probably something like 1,000 meters in terms of the freshwater content. Okay, so that's the Arctic. So here's some of our preliminary results from the Antarctic. So again, this is following the ocean heat content, this time down to 700 meters, and of course we have this in all the different layers. Following the idea that there's a mean here, there's a spread between the reanalysis products, so you get an idea where this is low, where the products are agreeing with each other, and then there are areas where there's greater disagreement. Again, there's only 3 observation-only products that we've got available here, but you can get an idea of the extent to which they differ from the reanalysis means. And then the reanalysis anomalies themselves. And again, you can see here there's a couple of products. This is the I think this is the couple product from, I think this is from GFDL, and this is the Gecko 2 product. So there's some quite big anomalies in these 2 products. The other products tend to be rather more similar to each other in terms of their anomalies from the ensemble mean. And again, just for the salinity fields, showing areas of agreement and disagreement between the salinities. And again, we can look at the observation products, and we can look at the rest of individual reanalysis products, and you can see where there are large anomalies. And I've got one more picture of this type to show. I'm not quite sure how I'm doing for time. Okay, so that's fine. There'll be some time for questions. So Francois Massonnet has done this preliminary analysis of Antarctic sea ice. And what he's done here is he's used a lot of independent data. So this is from the Aspect project. This is sea ice thickness data in something like 23,000 plus observations around the Antarctic region in different, I think the actual data set starts in 85, but so the analysis here is limited from 93 to 2005. It's the longest common period. And what he's tried to do is, so first all this data was rebinned into 1 degree grids, into 1 degree grid. The reanalysis data has a monthly sampling. So what he's looked for is consistency in the sea ice thickness in these 1 degree bins between the observations and the reanalysis products. And he's only looked at places where there are at least 4 observations of sea ice thickness in a month in a particular bin. And then he's asked, do the reanalysis products, do their sea ice thickness lie within the range of those 4? So basically, is it somewhere in the range, or is it outside the range of those 4 plus observational estimates? And perhaps not surprisingly, that when you start off with it, it's something less than between 40 and 50% of the bins show some level of agreement. That's not true of all the products. The Gecko product has a rather lower percentage of agreement, but none of them show greater than 50% agreement with these sea ice thickness estimates. So that's obviously sea ice is something very challenging to get right, and it's a new area for modelling. You know, the ice modelling is rather is not as advanced as ocean modelling, so it's obviously. But these are the kinds of comparisons I think we need to make to really understand where our products need to be improved. So again, I think this is a very useful sort of way of trying to bring these data sets together. And the fact that we can look at many data sets at the same time is, I think, rather useful rather than just having one group looking at their own product, because there's no way that you can look at everything. Okay, so I'll just wrap up. Just saying again that this Aura IP data repository is now well established and accessible for new projects. We hope people will use it. The COST project itself has another 2.5 years to run. So again, if people are interested in starting new reanalyses comparisons in different areas, we'd be very keen to hear from you. This polar project should submit an Arctic and Antarctic summary of the variability sometime in 2017. New studies are likely to be needed, so obviously as we start this, people are suggesting, well, we'd like to have new products that are not actually in the repository at the moment. So hopefully we will be able to bring a few new products into the repository to allow comparisons, particularly things like ocean heat and freshwater transports are not widely available from the reanalyses. And I think this is an area we'd really like to evaluate in these products, because after all, that's what you can't get at in any other way. We simply don't know what the heat and freshwater transports are until we get any data we have into a model and can then assess the integrals of those quantities. Polar regions may also provide strong constraints on the Earth's energy and water budgets, because what goes in and out of the Arctic is very strongly constrained by narrow straits. So in terms of trying to understand the global picture of energy transport and water transport between high and low latitudes, it's a very interesting area to study. And of course we know that polar climate change trends are also very large, and we need to understand those and understand to what extent we're reproducing them in our model systems. I think there's also some further work to do to try to align some of the polar metrics that we've been developing for looking at the reanalyses with the operational community, because there's work going on in the state of the ocean in CMEMS to try to produce metrics on a regular basis. And of course we should try to align some of the things we're doing for the reanalyses with the operational metrics for the Arctic that are being developed. I'll stop there. Thank you.